Hi, my name is Devin Pratap Singh, and this is the first assignment, and this is the implementation of AES 256 symmetric encryption in Python. So the goal was to securely encrypt and decrypt files using strong encryption algorithm. I built AES from ground up, including an S box and the inverse X box and sub-byte, shift rows. These are all the operations and sub operations in the AES. So sub-byte, shift rows, mix column, and other necessary options. This script measures the encryption and decryption speed and CPU utilization across different input sizes. So let me run it. As you can see, this is running, and after some time it will show us the results. So these are the results for this different speed results, and this is the memory results, and this is the CPU utilization results. So that's all for the first assignment. So this is the assignment 2 in which we implement RSA asymmetric encryption. So this is the code for the RSA asymmetric encryption in which we use two primes to generate n, which is p multiplied by q, and we compute the public and private key for this using the tOINT function and modular inverse. So messages are encrypted using this function and using public key and decrypted with the private key. So here is the decryption in which we are using the private key, and in this encryption we are using the public key. So I have included logic to handle different message sizes by converting the strings into the integer blocks, ensuring the messages fit within the key size limit. And to test the performance, here is the performance test. I measured encryption and decryption time for small and large messages, and compare how different key sizes affect the speed. The larger the key, the slower the operation, but also it is more secure. So these are the potential vulnerabilities. This is the mitigation strategies. Basically, we have to write all this. So this is the impact of key size generation. This is side channel attack. So mainly this was the code for this, that we have different message sizes, and for this we are encrypting the message and decrypting the message. So that's all for the assignment 2. Thank you. So this is the assignment 3 in which we make a password validator in which the user asks for some criteria it wants to check, and then sends in a list of password, and then the program tells us if this password is valid or not. So the user can send many criterias like uppercase letter, lowercase letter, number, special characters, and it can include only like 1 2 3 4 or 1 2 4 like this. So the password validator checks all these three conditions. So this is the AND clause, and it tells us if the password is correct or not. So as you can see, this is the list of password. This is the criteria. These are the four criterias, and this is the password list. So it checks if this password is valid or not. So this password is invalid as it is missing the uppercase letter, missing the special characters. So as you can see, this is the valid password as it is passing all the four conditions, and this is the password list by hard coded. If we send a text file, so this is the code for the text file. We are passing here the text file. 1 minute, where is it? Okay, this is the text file. Here we are passing the text file, and this is the text file, right? So yes, these are the missing criteria, and we can like check. We can tell the program to check 1 2 3 4 or 1 2 4, or 1 2, even 1 2. So it tells us if the password is valid or not. So this is the total valid password are 430, and total invalid passwords are 570. So that's all for the assignment 3. Thank you. In this assignment, we will implement a secure password storage system using SHA-256 hashing. So this is the code for SHA-256. We implement the SHA-256 from scratch, and here we are generating the hash function, and we are padding and parsing and setting the initial hash values. So this whole code just tells us what is the SHA-256 hash. So this is the code for that, and here is the main code. In this, when a user registered, their password is combined with a unique salt, and then that password is hashed with 256, and this hash is stored along with the salt like this. like salt is stored and their hash password is stored. So during login, the entered password is hashed with the stored salt and then compared with the stored hash to authenticate the user, like this. The hash of password is compared with the stored hash, and if it is equal to, then the login is successful. To prevent the brute force attack, salting is used so that identical password result in different hashes, and this helps securely store a credential and is a foundational concept in data security. So here, as we can see, the user is registering, and this is the password. This is stored like this in this format, this, and when the user logins, and it is printing as login successful because it is correct. But if we are passing the invalid password, it is giving invalid. So that's all for the fourth assignment. Thank you. So this is assignment 5 in which we are implementing a role-based authentication system, and where users are assigned different roles. Each role should have a specific access right to the files or data. So we are using password hashing and session management in this, and this is a web portal, web-based portal, and the admin assigns the editor and the viewer their rights. And so this is the portal. So first of all, I will show you the admin. So this is the admin portal. So as you can see, he can add new students, it can edit and delete those students, and it can run SQL query for the admin. It is only admin privilege. So it can manage users also, and here the admin can set like this user as a editor or viewer, and this editor as a editor or viewer. It can update these settings. So this is the dashboard, and yes, we can add new student from here. So let's log out and check the viewer user. So this is the viewer. As you can see here, we cannot edit any information. It can only view, it has only view access. So this is only for this user. And now I will show you the editor. I hope the password is right. Huh? So this is the editor. It can add new students and it can edit those students detail like this. I'm changing the name of the user. It can update it. As you can see, the user name is updated, and it can add new students also. Student updated successfully. So this is the web portal. So that's all about the fifth assignment. Thank you. So this is the assignment 6 in which we are implementing an access control mechanism for a distributed system using JSON Web Tokens JWT, and users should be able to authenticate, receive a JWT and use it to access secure endpoints. Ensure token expiration, validation and role-based restrictions are the main points here. So we are running the front end and the back end in the terminal in the background. So as you can see, this is the authentication step, and if we are not logged in, we can access the public. We cannot access protected as it says to log in. We cannot access the user information also because we have not logged in. And this is the admin only. So let's log in first. Okay, so password is password 123. As you can see, when we log in, we are receiving a JWT token, and this is the token we can use for request. And this is the access public. Welcome to the JWT authentication example. This is the access protected. Uh, you can see username Alice, and this is the user information. So username Alice. This is your token decoded information. Since Alice is not admin, we cannot access this. It says access forbidden. So now let's see the Bob, which is admin. So we received the JWT token, and this is the token for using for request, and this is for the public request, access public, and this is for protected. You can see the username is Bob, the user information is this, and yes, this is the administrator, and it is saying welcome admin Bob. This is admin only resource. So this is all about the assignment 6. Thank you.